Now our topic is representation of images formed by spherical mirrors using ray diagrams. So first characteristic for that suppose we are having both mirrors. For example, this is concave and this is convex, right? So the principal axis, it passes from C, F and P, 3 points. Here it also P, this is F and this is C. This is our concave mirror, that's why inner surface is reflecting. This is convex mirror, outer surface is reflecting, right? Now what happens, our object is at infinite, that's why lines are parallel with each other, and when they are reflected from the surface, they are passing from the P point. So this is the characteristic, whenever light rays are coming from infinite distance, they are reflecting back, and reflection, now that reflected ray is passing from the principal focus point. Now here similar, if our rays are infinite, they are reflecting back. So this is convex mirror, and characteristic is from diverging. So rays have to be diverged, and when we draw behind lines, they are intersect on one particular point, so that is F point. So here we are getting virtual image, here we are getting real image, right? Now second characteristic, suppose here also we are having same both mirrors. This is principal axis, this is C, F and P. Similarly P, F and here it is C, right? Now second, now all the rays supposed to passing from F point, and after getting reflection, see this is our concave and this is again our convex. So now after reflection from this point, they are parallel with this principal axis. So that is the characteristic here. If some lines are about to strike on this F surface, what they can do, they are after getting reflection, they are passing parallel with this principal axis. So that is the characteristic. Now if I am drawing normal to this surface, that normal is passing from C. Here if I am drawing the normal to that surface, that normal is passing from C, right? So similarly here if I am drawing normal passing from C, here if I am drawing normal, that will be passing from C. Now we are moving on to third characteristic. Similarly we are having two mirrors, one is concave, another is convex. I have to write points, this is C, this is F, this is P. Similar, this is P, this is F and this is C. Okay, now what we have to do here, now our light rays are coming from C point. After getting reflection from here, it will pass through, reflected ray passing through C point. Similarly any light ray which is about to pass through C, it will reflected in a same path. So that is the another characteristic of both the rays, right? So if I am drawing the further line, it will passing through the C here. Now fourth characteristic, again I have to draw both the mirrors, right? This is concave and this is convex. Now see, this is point P, this is also point P. Now whatever light rays strikes on this point P, it will reflected back. So these angles are similar. So that is the characteristic of this ray. Similarly, if any light ray strikes on this point, it will reflect it back. So that is the characteristic of this mirror, convex mirror, right? So these are the four representation of images formed by spherical mirrors using ray diagrams.